Yeah, grade 9, we have started this week the quadratic function. Okay, so I also give you some of the topic to find axis, vertex. Okay, so I want to give you some introduction and then come to the main part. The main part of the quadratic function is represented by an equation ax square plus bx plus c. Ax square plus bx plus c. So it has a square term, the x term, and a constant. And its graph is shown in a parabolic form, and it has different components, and that component I gave you the task in last 2 days to find it. The first thing I ask you to find the vertex. What is the vertex? Vertex is a point of change on the parabola, or we can say the minimum point, or it can come as a maximum point. But in this case, as the parabola is open up, we say the vertex is minimum. And I also ask you to find the axis of symmetry. Axis of symmetry is an imaginary line, a line which will break the parabola into two equal halves. So you see, it is just breaking the shape into two equal halves. So that line is called the axis of symmetry. And then later we are going to do about what is x-intercepts and the y-intercept. Okay, so I'm going to review some of the questions. Some of the students put a question that to re-explain about vertex and the axis of symmetry. If an equation is given like 2x square minus 4x plus 5 is a quadratic function, f of x equals to 2x square minus 4x plus 5, then we are going to write the standard equation under it, ax square plus bx plus c. So that will give the value of a 2, the b is minus 4, and the c is 5. So by using these three things, you can find first the axis of symmetry. An axis of symmetry has a specific rule, x equal minus b over 2a. This is the rule. So what we are going to do here is, now we are going to drop the constant value here. X equals to minus, what is the value of b? We have negative 4 over 2 times, what is the value of a? A is 2. So that will give me 4 over 4. The x is 1. So this x is 1 is called your axis of symmetry. So for the axis of symmetry, we have to use the rule minus b over 2a, minus of the formula, b, the value of the b with its sign, and 2a, 2 times the value of a. So that gives me 4 over 4, so x is 1. So this x is 1 is your axis of symmetry. The second part of this is, I ask you to find the vertex. To find the vertex we have coordinate x and y. In this x, already we got it from the axis of symmetry. The x is 1. Now we need to find the value of y. So how to find the value of y? So the y, we are going to drop the value of x back in our main equation. So that will give us the value of y. 2 x, how much we got it as? 1 square minus 4, x is 1 plus 5. So what I'm doing here, for the vertex x and y, x we can get it from the axis of symmetry. To find the y, I will put the value of x back in the main function. 2x square minus 4x plus 5. 2, x is 1 square minus 4 times 1 plus 5. So that will give me 2 minus 4 plus 5. 7 minus 5 is 3. So the value of y is 3. So I'll drop the 3 here. So 1 and 3 represent the point of vertex. Okay. So I hope the idea is clear now. So whenever you want to find the axis of symmetry, use the formula minus b over 2a, get the value of x. To find the vertex, x already we have it. Just find the y by dropping the 1 back in the given quadratic function. You get the y, put the x and y together, that is called your vertex. Thank you. Okay, so in yesterday's practice, some of the students also requested me for the review of domain and range, how they are going to find the domain and range of the quadratic graphs. Okay, so I'm placing here two examples. Let's check at the first example. In this case, the domain represents the moment of the graph on the x coordinate, So as we can see, the graph is going down, okay? So going down and going right and left, right and left. So here we can say the graph can be going unlimited to the right and unlimited to the left. So this quadratic function always have domain all real numbers, or you can in short you can write it as IR, all real integer, all real numbers. Okay, so domain of all the quadratic function is always all real numbers. So we have to now check the range, how we are going to calculate the range. Range is the moment of the graph on the y-axis from bottom to top. Okay, so from the bottom of the x-axis, negative side to the positive side. Or you can take it in an easiest way, that where the moment of the graph is, it is downwards. When the moment of the graph is downwards, you are going to take less than or equals to. So it's going downward, less than or equals to, from which point? From 4. So you can say that the range y, on the y-axis, the graph is 4 and less than 4. So whenever you see a parabola downwards, you can say y less than or equals to 4 is your range. Okay, so range always define the moment of the graph on the y-axis, downward, less than or equal to, upward, greater than or equal to. Let's check the second graph. Okay, as we discussed in the first point, that domain is always all real numbers. We can say IR. And the range we are saying the graph is going upwards. Upwards we are going to take greater than equals to. The y value is going to be greater than equals to. Greater than equals to from where? From the lowest point. And what's the value of y on the lowest point? -2. So we can say the range is greater than -2, because starting from -2 and going upwards. Okay, so this is how you have to define the domain and range whenever a graph is given. So hope the idea is clear. Now this day you are going to do a mixed review exercise based on both the topics, finding the vertex, axis, domain, range together. So watch the video carefully, step by step, write all the steps so that you can remember the procedure very clearly. All the best.